All right, welcome back to Mr. P Helps with Math. This is, well, calculus in this case. So this is Unit 0, and it's day 2, which happens to be simplifying equations with exponents and radicals by factoring. So we're factoring and solving even quadratics with different ways. So simplify the following expressions. So when you have a radical in this, the best way to simplify this is you're going to change this really into square root of 9 times 6, which is also 54. That's really the exact same thing, which if you think about it, square root of 9 is really square root of 9 times square root of 6. And the reason why you do this is because then you can simplify this. So we have square root of 9 is 3, so it ends up being 3 times the square root of 6. Now there's no more simplifying you can do here because the only factors of 6 would be 3 and 2, and neither of those are perfect squares. All right, so for the next question, so first thing I notice is I'm going to multiply, so 3 times 1/2. So if I leave 3x squared on top, so 1/2 times 3 makes 3/2. All right, and now I have a variable x on top and bottom, so whenever you're dividing quotient rule, you're always going to subtract. So what you get is you get 2 minus 3/2. Well, keep in mind that 2 is really, if I'm going to turn that into halves, that's really 4/2. So 3x to the 4/2, because 4 divided by 2 is 2, same thing. And that just makes it easier to subtract. So 4/2 minus 3/2 is 1/2. So we have 3x to the 1/2. Now, 1/2 power is the same thing as square root. So technically you have 3 times the square root of x. That would be the exact same thing. This. Okay. So for the next question, number 3, so we have 80. 80 can be split into 16 times 5. Sometimes it can take a little bit of time to figure out, what perfect square goes into it. So you just want to figure out, does 9 go into it? Does 4 go into it? You're looking for a perfect square, so in this case, 16 is the biggest one. Now, x seventh can be split up into x to the second times x to the second times x to the second. That's 2, 4, 6 times 1 more, because when you're multiplying, you are adding the exponents. All right, so 2, 4, 6, and that becomes 7. Of course, these are all under square root. Now, the reason why I do that is because, well, square root of 16 ends up being 4, so this is 4 times the square root of 5. Can't do anything about that. Now, x squared turns into x, and this x squared turns into x, and this x squared turns into x. And then you can't do anything about the square root of x at the end. So now to clean this up a little bit, so this is x times x times x, that's x cubed. So we end up with 4x cubed, that's on the outside of the radical, and 5 times x is 5x inside the radical, and then there's nothing else we can do. That's as simplified as we can possibly make it. All right, so we have a lot of rules when it comes to properties of exponents. I know I referenced a lot of these on the warm-up. So product rule is when you have multiplying things with the exact same base, you add their exponents, so m plus n whenever it's multiplication. If it's division, you subtract the exponents. When it's a power raised to another power, you multiply. That's when you multiply the exponents. And then when you have a leading coefficient in a term, just make sure that that 4 also gets raised to the power, because it's like the same thing as it being in the parenthesis. Negative exponents are the same thing flipped. So for example, we have x to the negative third flips to 1 over, because anything over 1 is itself, flips to 1 over x to the third to make it from negative to a positive exponent. Typically, negative exponents should not be left in your answer. This is also a negative exponent, so we flip this. That would become a to the positive m. Same thing here, so it's basically just going the opposite direction. And anything to the 0th power is 1. Doesn't matter if it's a variable or a constant, doesn't matter. Anything to the 0th power is 1. All right, so example number 1. So we have negative square root of x over 5 to the x to the negative first. Now, first thing is we have x to the negative first. So we know that that x to the negative first is going to go to the top. So I think the best thing to start off with is to separate the constants. So we have this negative sign here. That's really a -1. And then we have the 5 on the bottom. So that's really -1/5. I'm sort of separating the constants from the numbers. So the square root of x, as I talked about in the last one, is really x to the 1/2 power, because it's x to the 1 and 2 is the index of square root, so it's x to the 1/2 power over x to the negative first. Now, x to the negative first on the bottom really translates, moves it up to the top, becomes plus 1, because it becomes the opposite. So 1 plus 1.5, 1 is really 2 halves, 2 halves plus 1 more half makes 3 halves. So we end up getting x to the 3 halves. And then we still have that negative 1/5, and that's as far as we can take it. So that is our answer, simplified. Okay, when you look at this question, the first thing you probably notice is that we can factor out a GCF. Both 2 and 4 can both be divided by 2, and both of these terms have x to the 1/2 power. So we're going to factor that out. So we're going to simplify by factoring. So this term times 1 is this, check, because it's literally the same thing. This times 1 is this, plus, well, 2 times 2 is 4. 2 times 2 is, or you can divide. 4 divided by 2 is 2. X times what is 5 halves. Now, once again, so it's multiplication. So that would end up being 3 halves. Because, once again, so we have 1/2 being multiplied by 3 halves, and that ends up giving us 3 over 4. All right, scratch that. Once again, forgot my own rule there. So we're multiplying. So this is not power to a power rule. This is product rule. So this is multiply. A base times the same base. So that means you're going to add the exponent. So 1/2 plus 4 halves is 5 halves. So once again, forgot, this is not power to a power rule. This is product rule. So 1/2 plus 4 halves is 5 halves. And that's as far as you can take it. So that has been simplified. All right, so let's take a look at the next one. It says use the quadratic formula. Now, first of all, let's go over that. So negative b plus or minus the square root of b squared minus 4ac, which is called the discriminant. That determines how many, all divided by 2a. That determines how many solutions there are. So if it's anything above 0, it's going to be 2 solutions. If it is 0, it's going to be 1 solution. And if it's negative, then it's only going to have 2 imaginary solutions. Now, a is always the coefficient of the x squared, b is the coefficient of the x, and c is always going to be the constant. Now it's just a matter of taking these and plugging it into our formula. So negative 6, because b is 6, plus or minus the square root of 6 squared minus 4 times a times c divided by 2 times a. All right, so let's clean this up a little bit. Negative 6 plus or minus 6 squared is 36. Negative 4 times 4 is negative 16, and then all divided by 8. All right, so once again, 36 minus 16, so we have negative 6 plus or minus the square root of 20 over 8. Now, the last thing I see here is that I can, actually I can do 2 things. First of all, the 6 and the 8, that can be simplified. 6/8 divide both by 2, and that gives you 3/4. Okay, so we have negative 3 plus or minus square root of 20 over 4. But this can also be simplified one more time like we did in the warm-ups, because square root of 20 is really 5 times 4. And so there's our answer, negative 3 plus or minus. So if we turn that into 5 times 4, square root of 4 is 2. So 2 times the square root of 5 over 4. That's as far as you can take it, and those are your 2 solutions. All right, example number 4. So find the zeros of each quadratic polynomial. So this one is factorable. That's the nice thing about it. So this is x minus 3 times x minus 2. So x minus 3 times x minus 2 equals 0. I think we're missing our equals here. So set it equal to 0 and solve. So that means x minus 3 equals 0 and x minus 2 equals 0, which means our answers are 3 and 2. All right, question B. So this time you have what's called a leading coefficient. You have an A term that's not 1. So there's multiple strategies for doing this. Me personally, I'm going to multiply a times c, get negative 6. And then I'm asking for what's the split on negative 6 that also adds up to 5. That would be 6 times negative 1. So I'm going to do the same thing I did over here. So x plus 6 and x minus 1. But I have to divide both numbers by the leading coefficient. So that's 2. All right, so I end up 6 divided by 2 is 3. And since 1/2, x minus 1/2 is the same thing, or you can just slide it up into the front spot. So that's 2x minus 1 equals 0. And now, once again, all you have to do is set each factor equal to 0 and solve. Now, once again, x minus 1/2 is the exact same thing. You know, the answer is going to be 1/2. Right? Because when you add 1 to the other side, you got... So 2x minus 1 equals 0. I know I'm trying to save time, so add 1 to the other side makes it 1, and then divide by 2, and what do you get? You get 1/2. But once again, right here, if it's minus 1/2, it's going to be the opposite. So x plus 3 equals 0. You end up getting negative 3 for the other solution. All right, and that looks like that is it. So this was lesson number 2. So once again, we were solving our, so we got radicals in here and we've got power rules in here. Thanks again for watching, and I'll see you in the next video.